Okay, hello. This is project log or client project log for the safety hurdle. Have I ever filmed a video on this? I think I have. Let me just check on my iPad. Just a second. This is for future me. I'm doing some self-care, okay? Cut me some slack. I think I have filmed a video of, a project log for this. But no, not at all. This is the first project log. It's only going to be, I guess, a first in a few. But basically, what this is, okay, so let me show you. Let me take you to the very beginning. Right, so this is another client. It's not the same guy who ordered a floor curling broom to be electronic. That's a different client. This client, what he wants is simple. There is this, I'm pretty sure I have a picture of it somewhere here. Not here. Okay. There are these things called hurdles. Why am I in incognito? There are these things called safety hurdles. Yeah, so, and what these are, yes, thank you. And what these are is basically, actually, no, these aren't the ones that I was looking for. But, okay, so let's start here. So you know what a hurdle is, right? It's basically, it's an obstacle, right? You put it on obstacle courses. Some athletes use it to train, that kind of hurdle. It's basically just a bar set to a certain height. Now, but the downside with these hurdles is that if someone gets stuck or if someone, fails the obstacle course, these hurdles, they don't really move. So there's a high chance that you're going to trip over the hurdle if you fail to jump over it and get an injury. So what they made, I don't know if this is the only place that made it. There's probably a lot of other safety hurdles that are designed like this, but what this basically is this is a safety hurdle. Now, the difference between a normal hurdle and a safety hurdle is simple. Here, in this, where my fourth finger is pointing, in this region, there is a contraption that allows the hurdle bar to just bend or to just flex or just move out of the way when it collides with, I guess, something like a human body. Now, my client actually allowed me to film a couple. Jesus. Okay. My client actually allowed me to film a couple of pictures of these hurdles. So let me share those with you. No. Oh, God. Okay, so I took some measurements, and basically the contraption that I want to show you is this part. This is the contraption that makes the hurdle, quote-unquote, safe. And how it works is, yeah, it bends like this. There's tension on the wire. There's enough tension to keep it in this 90-degree angle, shaped like this normally. But then the tension isn't strong enough that it resists being moved or bent. So this is what a safety hurdle is. Now the problem with this safety hurdle, you're gonna see her a lot, but I don't know, not just yet. Anyway, the problem with this safety hurdle, as you can see, is that it's very bulky. This, from this end to this end, that's about 1 meter. And from this end to this end, that's about 0.5 meter. And that's really not ideal when you're trying to use this thing to warm up or use it to do a pre-workout stretching routine, which these are actually used for. So, my client wanted me to make a version that bends. Now, I have been working on that. Firstly, if I want to make a version that bends, the biggest obstacle is to make the contraption itself this part bend, right? And bend in a way that does not stress the contraption itself. So if I were to just force the original contraption, this one, where is it? Look down, camera. Where is... Yeah, here. So let's say, you could say, well, why don't you just bend this down and fix it there? Well, the problem is that would put strain on this cable here, and that's definitely not healthy for the contraption itself. So this was my initial design. I pitched this idea, not like this. I modeled it, obviously, but I pitched this idea, and he really liked it. What this idea is basically, it is using a latching, a latch. It's an interesting latch. So this is the view from the side, and this is the view from behind, so from here. And basically, this aluminum pipe has this cutout here it's like a moat that allows this pin to move. And this pin is connected to a elastic wire here. And this elastic wire, when fixed into this position, creates enough tension to hold the hurdle in place like this, right? But then, as you can see, this cutout here, it's made in this sort of J shape. So when you're not using it and when you want to bend it and store it, you can just pull it down and move it all the way up here, and that releases the tension. So there's no tension here. So the hurdle that was initially like this, it's going to fold like that because there's no tension holding it up in place. That's the initial idea. The final idea is quite similar, but I made some deviations from it. Now, this was problem one solved. The second problem of making something like this bend is, how do you make it actually collapsible? Now you might think, oh, well, that's an easy problem. And well, it kind of is if you just want, 4 of these pieces to bend like that. The problem arises when you have a design like this, where there's 1, 2, 3 axes conjoining at one point. So that really makes it a bit more complex to design a collapsible structure. So let's see here. So the way I wanted to do this initially was with welding. But the problem is I have not learned how to weld metals yet. That is a very handy trick that I plan to pick up in the near future, but for now I have not learned it. And because of that, and because of my experience with 3D printing, and I know I can make hinges that are strong enough with 3D printing, especially on a scale this big, the size of the hinge is unlikely to hinder the design of the product itself. So I opted for a 3D printed hinge design. And so here you can basically see how I sketched everything out. This is the view from up top. And then when you fold it from up top, it's going to look like that. So there's this hinge in the middle that folds this way. And then these hinges, these collapse this way. And then this makes this M shape right here. And then this M shape makes this, collapses into this single line. Now, then the question or the problem that I posed earlier was, well, what about this one? This this pipe that's vertical to the plane that we're working on here. Well, the way I solved that problem was actually I just copied the initial design here. Now this initial design uses a hinge here, and this hinge is shaped in a way that yeah, here. I think this is the best example of how this hinge looks like. But basically, it bends this way. Not bends, but it collapses this way. It collapses this way. And so I took that exact design and implemented it. So, well, not here, but I implemented it up here. And I'm going to show you that in a bit. But that was basically the sketch. And then I made the initial version, which I do not possess right now because I am not someone who likes to store too much irrelevant information. yeah, if I save every single version, my computer is going to run out of storage pretty soon. So this is the end version. And so let me explain how this hinge part works. So this hinge, this view is not most comfortable. So this is the hinge that props up this vertical pipe. And basically it has its axis of rotation in here. So it turns like that. And once folded, it looks like this. So this hinge has folded like that. Oh, my hand is wobbling, I'm sorry. But the hinge folds like that. And then this, collapsed M shape, or in this orientation it's a W, but this collapsed W shape is what you see here, basically. So it's the same design, and the only part that's really changed is that part. This part up here. Let's see this in full form. No. Let's see this part. So this is the part that has changed, this part. And let me show you how that part, the contraption itself has changed. So we're going to go here and look at a cut version of the design here. It's very simple. I have not added the wires because I don't like drawing parts that I'm not actually going to print in Fusion. So these are actually either parts that I'm going to print or parts that I have to get manufactured. And the dimensions actually matter. Whereas for flexible, cables, the dimensions tend to vary because, well, they are in the name itself, flexible. So how does this part work? Well, it's actually really simple. And I have this drawn up design here. So let me explain it with this first, and then you can see the model up there. But basically, this is the hurdle itself. Where's my pen? There's my pen. Okay, so this is the hurdle itself. It's connected via a elastic cable to this plug back here, and then in between this plug and this hurdle, there's this ring that's tied or fastened, at a specific point in the cable. We'll have to experiment where that specific point is, but no big deal. And the way this hurdle, which is normally supposed to be stored like this, the way this hurdle props up is very simple. You basically pull this plug, which is connected to this cable, as you would like starting up a chainsaw. So you pull that, and then until you get this ring out of the aluminum pipe. And once you have this ring out, the hurdle is probably going to be taut like this. And so you're going to fasten the ring right here, this is a plastic fixing point that's shaped like a inverted L. You're going to put the ring here, and that's going to lock the tension on the hurdle. And then once you're done using the hurdle and you want to put it away, you just remove the ring there, and then let go, and then the tension will fall and the hurdle will go back to its like droopy state. So that's basically this contraption up here. This is just a bit cleaned up. So there's going to be a knot here, and then this cable that's going to lead out through a knot here that's going to fix the cable in place so that it isn't released. And then let me just draw a sketch so that I can explain with more ease. So there's going to be something like a knot here, right? You can't really see that, can you? No, you can't. Okay, well, let me explain with my cursor, because my cursor is big and pink and very, very visible. Now, there's going to be a knot here, and then there's going to be a cable leading out here, and then here there's going to be the ring that I mentioned, and then the plug that I mentioned. The plug is only here so that the cable doesn't end up being lost in the middle of this pipe, and that would be a real pain. So I would, very much like to avoid that kind of accident. So that's why the plug is there. And also it's better for aesthetic purposes, right? You don't want a knot hanging out of a product. You really just want, a nice 3D printed plug if you can afford it. So that's how it works. And then you pull it back, and then you hang the ring here, and so that keeps the tension on all of these parts, or on this hurdle. Come on, hourglass, thank you. On this hurdle, and it pulls it taut. That's basically how it works. The only part I'm really worried about is the tension and durability of the cable that's being used here, because this entire contraption is pretty light, granted, but then again, the cable itself is also going to be very thin. So we'll have to check when we actually make the product itself, but right now I'm not too worried. So yeah, that's how this thing looks like. It's about 1.10 meters, 1.1 meter wide, and about 0.5 meters in length. And this height can be adjusted from 0.5 meters to, actually I haven't checked, to nearly a meter tall, which that's pretty impressive. I don't know what you would need a meter tall hurdle for, but we never know. So yeah, and then once it's folded up, it looks like this. Oops. Yeah, it looks like this in all its glory. This is about 10 centimeters wide, about 50 centimeters or 60 centimeters long, and about 10 centimeters tall. Yeah, so the client's very happy, obviously, because it is my project, or because it is me, because it is Jaspadale Studios. The client's very happy, and I would also be very happy in a couple of days, I guess, when I actually bring this thing to life. That's when I'll be happy. For now, it's a bit of anxiety, but yeah, that's going to be it for this project log. I'll upload this one, and see you guys again pretty soon. Bye-bye.